Hello, we're back. This is Microsoft Ignite and Zed. I'm here with a special guest. For those that are watching, please submit your questions via the question box below. We're going to talk all about app service. But before we do, why don't you tell us who you are and what you do, my friend?
All right, my name is Nazim Lala. I'm a software engineer on the Azure App Services team. I pretty much focus on open source software stack, enterprise, and security features.
So let's talk a little bit about what app service is, why it's sort of something that you should be using, and then we're also going to get into how OSS sort of feeds into that. Is that okay?
Yeah.
So let's start with app service.
So Azure App Service is a fully managed platform for running your web and mobile applications in the cloud. It makes DevOps extremely easy for you. It makes scaling up and down extremely easy, and it's loaded with a whole bunch of enterprise and mobility features as well to make the entire process of getting your application from its stage of infancy when you're still developing things rapidly, all the way to like an enterprise-grade production app.
So let's talk about, one of the things that confused me initially, and hopefully you can help me with that, is app service was actually, there was like mobile apps, there was web apps, there was logic. Can you sort of give us this whole hierarchy? Because I want to make sure that I have in my head which part of it we're talking about when we look at each one of them.
Absolutely. So it's a blend of several different products. One of them is web apps, one of them is mobile apps. There's also something called API apps.
Okay.
And the other thing that we also own that doesn't tie in very neatly, but it uses the same framework that we have built, is also called Azure Functions, which is essentially the serverless technology. So you basically write an application without keeping in mind anything like what it needs to host that application. You write an application and you get charged based on the number of times your functions get called. So that is also owned by us.
That's
so all of those,
interesting, yeah. So let's go through each one. Let's go to the ones that obviously make the most sense, that people will be like, oh, I totally understand that. So let's start with web apps. What is it about web apps that should be good for everyone to use, especially for those that use OSS?
Okay, so let's just talk about web apps first, then we'll move into OSS.
Love it.
So for web apps, essentially we have a whole bunch of application stacks that we already support. We have amazing sort of code integration, so you can have any sort of like, if you have Visual Studio Team Services, or if you use Visual Studio Online, GitHub, any Mercurial-based source repository, anything of that sort, and you have your code in there, you want to just automatically do continuous integration and continuous deployment to some environment in Azure. Azure App Services is it, right? And web apps is sort of really what you want to use. So it'll automatically let you deploy all these things directly from source control. You can also do things like do staging slots. So essentially, if you have a production app, you can have a production slot, and you can even have a staging slot, a test slot, and each of these slots, you can actually have different even embedded tests in them. And then you can automatically swap these slots. So for example, you can have a production app and a test app, and if the test app passes all the tests, you immediately swap them with the production. So they're completely seamless. You have two separate apps, and then completely seamlessly you migrate one from the other. Right?
And that's an interesting thing, right? Because one of the things that I worried about when you initially said, hey, you push your stuff up to source control and it moves it automatically. Well, how do you know you want it to be there all of a sudden? Let's talk a little bit about the slots, how you would kind of set that up, and why it would be a good idea to do that.
Awesome. So typically most, once you start from your infancy stage, when you're just sort of like rapidly deploying, trying to get a prototype up and ready, then once you have real customers, you need to take care. You need to make sure that the customers don't break. And at that point, you need to essentially set up two slots, one essentially for production and the other one which is sort of like a beta app, right? And then as you keep working on it, you can either do essentially an automated deployment. So essentially you run through automated tests, and if they pass, you basically automatically switch slots. Or you can do something else as well. One of the things that we actually let you do, which is pretty cool, is called testing in production. What it lets you do is that if you have multiple slots, it lets you choose a percentage of your traffic to go to your test slots. So you can basically say, hey, I want 5% of my traffic to go to my test slot and 95 to my production slot. That way you get testing even in production for your stuff that's in your staging slot. The other thing that you can also do is that in your main app, you can even provide like customers like with a little dialog box that say, hey, you want to try out a beta app? And if they sort of opt into that, you can essentially set a cookie for them that always routes that customer to their staging slot instead of the main one. So there's a lot of really power in sort of like doing automated like A/B testing, or even sort of like swapping slots and managing the production versus non-production environments.
And that's really interesting, because like you can do some serious A/B testing that
Absolutely.
way with routing percentage. So let's talk a little bit about, you talked about the automated test that lets you go from sort of the testing slot to the staging slot or to the production slot. How does that work? Are the tests inside of app service? I mean, where are these things living?
Yeah, so it really completely depends on you. So for most of the time, what happens is that as part of your deployment itself, you can actually have what we call a custom deployment script. And in a custom deployment script, you can actually specify what kind of tasks it needs to run and pass for it to actually be considered a successful deployment. If you're going to write your own bash script or your own shell script, it can do pretty much anything it wants to. So in the case of like a Visual Studio project, you would actually have Visual Studio tests embedded inside your project and actually execute them. And if all of them pass, it basically says it's a successful deployment. Or you can just write a custom script that basically says, okay, install all the stuff and then call some external entity that'll actually do performance testing or whatever testing it needs to do on your endpoint, and then it makes a decision of whether your test passed or not. So you have a lot of flexibility.
Is that like I'm trying to see, does that live in the app service or does that live in VSTS or in Visual Studio?
So the answer is that it depends, right? It could live inside your app service. So as part of the deployment of your project, you also deploy your test binaries along with it, and it runs locally within your app. Or it could be something completely different. So like Visual Studio has like a performance testing thing, so it externally runs a bunch of tests. So you could also build a custom deployment script that uses something like that. So it's like an external service to test your app. So you can do either or both.
And that's cool because web apps have sort of evolved a long way from just being like, here, put your application here. Now it's literally something that can scale, something that can have multiple slots, something that can be part of your CI, CD sort of pipeline. It's pretty cool.
Absolutely.
Now, tell me about sort of scaling up these things, because traditionally, if I'm using my own VM, there's some things you have to do. You have to do some farm stuff. Tell me about how app service scales for web apps.
Okay, so you have multiple options really to scale. One thing you can do is just manually scale. You can go to the management portal or go to our CLI tools and just essentially have a slider and you can scale it up and down. That's if you want just sort of manual control. The other option you have is to do something we call auto scale. And auto scale essentially gives you control over a bunch of triggers. And using those triggers, you can either scale up or scale down as well.
Right.
And some of these triggers would be things like percentage of CPU usage, percentage of memory usage, absolute CPU, absolute memory usage, request like HTTP request length queue. So things of that nature. So example, if you have an app that uses a CPU a lot, you can basically have an auto scale rule that says, hey, if my CPU goes over 80%, just go add 2 more scale units, or like add 2 more VMs essentially to the list of to the app service plan that I have. So give it more. And you can also do the same and go backwards. And you can basically say, hey, if my CPU consumption drops below 40%, shrink the size of instances that I have. So shrink it by half, or I can shrink it by a specific number, like shrink it by 1, 2 instances, things of that nature. That helps you like save money as well.
So what do I have to do? Like, is there anything I have to do when I scale up? Is the routing going to happen by itself? What about the cookies, because the cookies are, if they're going to different slots or different machines, I need to know the identity of the person. How is that all sort of managed?
Right. So as part of our service, we actually host our own front-end logic. So let's think about it as load balancers, right? And the load balancers that we have take care of routing your application to multiple instances. If you have multiple instances, we'll take care of routing it between them, right? And you also, as a developer of your application, you get to choose something essentially like if you have a customer and you always want to have that particular customer go to a specific instance of your app, you can even do that kind of thing. We have this cookie called the ARR affinity cookie that you can sort of tie in and force customers from, say, some regions to go to a particular instance of your app.
And that would be like, for example, if you know customer A is the most important and they're going to be loading up 100 things in their cart, you want them on a bigger instance.
Yes, that's one of the reasons, absolutely.
That's awesome. So what else about web apps should people know about that's new that they maybe have not heard about?
Okay, so one of the things that I didn't really talk about is that it really is completely enterprise ready. So if you have sort of like higher security and isolation needs, app service is for you. So we have the ability for you to talk from your app in the cloud all the way to a database or some other resource that's on premise. For example, some people they're not comfortable with migrating sensitive data from on-premises environment to the cloud. So what you could do is you could set up what we call VPN point-to-site connectivity, and it lets your app in the cloud talk directly to the database on-premise, as if they were part of the same virtual network. And if you want even further isolation, we have something called app service environments. You essentially get an entire app service scale unit all to yourself inside your own virtual network, which basically means you can seal it off with network security rules as you please. So you can completely make your entire app service environment invisible to the public internet.
That's amazing. So I have a couple of questions about that. If you're using your own private VPN to get sort of your database stuff, is there a latency problem? I mean, or is that just a question of bandwidth?
So it really depends. So if for most applications, I don't think there'll be much of a latency issue. But for really big enterprises, like they have what we call express route circuits. So essentially, we support that as well. And what express route circuits are, is essentially a telco level, a telecommunication company level circuit, dedicated circuit that connects your on-premise environment to the cloud environment. So you have no latency to worry about, and you have sort of dedicated fiber like network connectivity between your environment in the cloud and your sort of on-premise environment, and you can use that as well.
That's actually really amazing, because there are some, like by law, that are required to keep their data on premises, or let's say they have to be HIPAA compliant. Absolutely. Now you can sort of do the next sort of level cloud applications and still have them locally. Tell us a little bit more about the private network thing that's in the cloud. You mentioned that. What does that look like? How do you set that up? And what guarantees do people have if they're in the enterprise and want to use sort of app service?
Absolutely. So in an app service environment, you essentially, your entire scale unit deploys within its own virtual network. And this virtual network, you completely control what the security rules for it. So essentially, they are controlled by a set of network security group rules, and you can essentially say whatever you want. You can basically say, hey, this entire VNet is completely cut off from everything except these 3 IP addresses can talk to it, for example.
Wow.
Or what you can do is you can basically say, here's my VNet with all my app service environment stuff, and you can actually have your own dedicated web application firewall sitting in front of it. And it accepts public internet traffic, but your app service environment only accepts traffic from the WAF. That way, everything that comes into your apps, it's been sort of filtered by a firewall already.
Gated, right.
Absolutely.
That's amazing. So let's move on, because we're running out of time. We have about 10 minutes left. Let's talk about sort of API apps. Is API apps just another variant of web apps that services sort of API RESTful type things?
Yeah, so it's essentially built on the same platform. Think about web apps as like the basic platform on top of which we build things, right? So API apps are built on top of it. Mobile apps also built on top of it. So web apps are like the basic thing, right? So any functionality that you have in a web app automatically is available for you in these other kinds of apps. But those other kind of apps are specialized to serve very specialized needs. So in the case of API apps, we make it absolutely easy for you to do sort of API level versioning, load balancing, A/B testing at an API level, things like authentication and authorization checks, doing that at an API level, sort of API routing, a lot of stuff like that. It's very API specific. We essentially add extra features into that, right? And the same thing for mobile apps as well. We essentially make it very easy for you to write a mobile app that works across any device or run on any platform. And we give you a good runtime that you can use both on the client side that communicates and lets you do CRUD operations and things like that on the server side as well.
So if you're thinking about sort of app service, you should start with, okay, think of web apps as the base. API apps adds additional features that are specific to APIs.
Yes.
Like versioning, and you mentioned a couple of others, but it's not clear to me what more there needs to be. You mentioned security, but how do you manage like the cookie, you know what I'm saying? Usually if you're doing that kind of authorization with APIs, you have to have some kind of JOT token that's somewhere. How is that handled?
Right, so API apps is its own sort of stack for doing authentication and authorization, including you can do some pretty advanced things based on like client certs and stuff like that, client certificate authentication. That's not to say that we don't have a functionality like that in web apps. So one of the things that you brought up was pretty interesting, like just like JOT tokens and stuff like that. Like what if I have an application that just wants to do Azure Active Directory authentication or cross auth with anything like Facebook or Google or some other authentication provider? In web apps itself, which is like the base of everything that's built on top of it, we already have something called authentication authorization provider. And what it lets you do is that without writing any code whatsoever, it lets you inject authentication authorization not only from Azure Active Directory, but even from these other providers like Facebook and Google and just Twitter, and just adds cross-auth support directly into on top of your web app without you having writing any code at all.
So how does that happen? I mean, I'm feeling like look, we're programmers, right?
Yes.
And if someone says you don't have to even write a single line of code, my bits are flipping everywhere. And I'm thinking, whoa, there's some corrupt memory. I didn't hear that right. How does that actually happen, though? What do I do to enable that?
Absolutely. So essentially, when you go to the Azure Management Portal, you choose to enable some sort of application authentication for your application. And when you choose a provider, like let's say you choose Google as your authentication provider, what we will do at that point in time is we will essentially ask you to give us an API key in a client secret.
Right, which you get from the providers.
Exactly.
Okay.
So I can go to Google's developer portal, for example, and basically say, hey, here's my application that I'm creating. Give me a client ID and a secret that I will just port over to the management portal. And once I put in the management portal, what happens is that as part of our process, as a request processing pipeline, we actually have a module sitting in there that does this authentication for you automatically. So every request that comes in, before it gets to your application, we have something sits in the middle and does this OAuth dance for you on your behalf. And if it's successful, you just end up with the JAR token is injected inside the request itself, and it's passed in as a header and the body to the request, and then the request from your application, you just read the JAR token and you can parse whatever claims you want at that point.
So I understand like that from like a middleware sort of pipeline kind of thing in .NET, right? Because Owen, which was a precursor to what .NET is now, would sort of inject that stuff. I understand that, but how does that work, for example, if you're doing a Node app or a PHP app? Does that work the same way?
So you have to write a little bit of code. So like OpenStack and stuff like that makes it very easy, right? Because you just go to whatever current identity.principal and everything's already there for you. It makes it very simple. But what we do for these other apps as well is that these other frameworks, we just pass in the JAR token, and we pass in a collection. Think about them as sort of like environment variables, key value pairs, with all the sort of the claims in there as well. And then you can just manually go validate whatever you want to at that point, right? Like you can basically say, hey, for every incoming request, if the token is valid, I want to check your group membership. And only if the person is a member of a certain group that I expect, then go ahead with this app. Otherwise, just go return back a 403 or something.
And that's amazing, right? Because generally, if you're using .NET, it's in the identity, right? And the by principle, you just pull all the claims out, whatever you want to do, and it will it automatically sort of, if you have an authorized attribute on your controllers, it will respect that and do the redirection and everything.
Correct.
That's
absolutely
pretty cool.
Yeah.
So now here's we have about 4 minutes left. Here's the thing I get confused about when it comes to API apps. I understand. Mobile apps. Is it just a web app with a database and other things? Or what is it? Because I've heard that if you think of a mobile app, it's a web app plus stuff.
Correct.
So tell us what the plus stuff is and why it's important.
Okay, so there's two pieces to the plus stuff, as you put it. One is on the server side, and the other piece is on your client side with your mobile application you're writing. So think about it as you have an iPhone that you're writing an application for. So for the client side, your iPhone, we essentially give you a web SDK. Right? And you can program against an SDK and do things like authenticate your user and do basic CRUD operations on their behalf and things of that nature. And on the server side, we build a runtime that makes it very easy for you. So like, for example, if you are writing a game like Angry Birds or something, you have a whole bunch of people who want to go and you want to authenticate. People don't like writing back-end code, right? Especially people who want to write games and stuff like that. That's the last thing they want to do.
Not only that, but we don't want to write that code, right?
Exactly.
You want someone smarter to write that code.
Exactly. So what we do on the server runtime side is that we do all that code for you. So you don't have to write any sort of state management operations or any database or any of that stuff. We take care of everything for you. You just tell us from your SDK side, you want to create a user. The user is doing some sort of operation. You just specify sort of what kind of CRUD operations that user would perform, and we take care of all the back-end stuff for you as part of our runtime. That's essentially the value proposition over there.
And then I understand, if I understand this right, you also make push notifications
easy and agnostic to provider. Absolutely. So if you use Apple push notification service versus something else like that even Microsoft provides, we just support all those push notification models. So essentially, you write this application once, and then it doesn't matter what device it's targeting, you have some mechanism for your server side to essentially push notifications directly to your client. So now we have 2 minutes left, and we have two things to talk about. So 60 seconds for each. Logic apps and how OSS fits into this whole thing. Absolutely. So Logic Apps is slightly different from the rest. Think about Logic Apps as sort of like a WYSIWYG designer for your applications, right? So a lot of people are like, just let's think about like someone in the finance department of a big company. Right. They're not exactly programmers, right? But they have a good idea of what business logic they want to implement in their application. So Logic Apps gives them a very easy way to design this experience. So you just drag and drop things saying, okay, the user has this sort of stuff, this is kind of inputs they have. I have this sort of database which has these kind of entries. And you can just correlate things together, and it automatically builds an application for you. And that's sort of what Logic Apps does. And as far as the open source software stuff goes, we just entered the foray just about 2 weeks ago, where we've sort of announced a release for our public preview for web apps on Linux. So now, before we were primarily a Windows shop, all of our apps were running on VMs that essentially were hosted on Windows, and now we essentially run on Linux. And so this gives us the ability to target customers that we have never been able to reach before, and also it just kind of helps us out with compatibility issues that people have with running some sort of like software stacks on application stacks on Windows as compared to Linux. Well, this has been awesome. Thanks so much for your time. And we're going to go to a session which is already in progress.